Good morning, students. It's Miss Wilcox here. I hope you're all doing well today. Thank you for tuning in for this video. So today we're going to talk about Pythagorean Theorem. It is accredited to the man Pythagoras, who lived from 570 to 490 BC. Many researchers nowadays say that he may not have been the original creator of the Pythagorean Theorem, since he did not physically record any of his writings and discoveries, and there have been ancient artifacts found now where this concept was used much earlier than his lifetime. So today, once you've looked, if you'll see on the documents that I've sent you, there is a foldable you can use. You do not have to use this foldable. It is not required or necessary, but it is something that I would encourage you to use if you have a printer at home. If not, that's okay. But if you do, I think it is a very useful tool to keep your notes organized and help you to just get a better understanding of the material. If you would like, just get out a sheet of notebook paper and follow along with me as you look over your document and watch this video. So if you are going to use the foldable, once you put it together, it will look something like this. You'll have 3 tabs on the bottom. It'll have the theorem on the front side, and you'll have 2 sheets of paper. And you'll have a dotted line that you'll cut here. You'll have sections that say cut this piece off, and those are the little sections that give you your tabs. And then you'll fold the 2 sheets of paper together and staple them at the top to make a foldable that opens with flaps for you that we're going to talk about today. So we're going to open to the vocabulary tab, and we're going to look where it says example 4 and 5 to find the unknown side lengths. So underneath this, before we can start finding these unknown side lengths, we need to learn a little bit about the theorem. So we know that all triangles have 3 angles that add up to equal 180 degrees. We also know that with a right triangle, there is one 90-degree angle, and the remaining 2 angles must be smaller than 90 degrees so that the property remains true. So for this theorem, we're going to have an equation, an algebraic equation that says a squared plus b squared equals c squared. Now, if you look to the side, there is a triangle, a right triangle with 3 blocks that are documented to show you the length of each side. So if you count up the number of blocks in each of these large squares, you'll find that you'll have 9 blocks, 16 blocks, and 25 blocks. What this is doing is reminding us of counting area, which is a middle grades and elementary school math concept, and we're just applying it to this equation. So if you want to write those numbers into your blocks just like I have here, you are more than welcome to do so. Or if you would just like to draw an image, you can use a calculator or a ruler today to help assist you if you need help with the radicals and the square roots, if you need to just draw out an image and you want it to look really neat. So whatever you need, just get that out and apply that today. So we're going to plug in these numbers here. These numbers are going to be very significant for our equation. So if we see a squared plus b squared equals c squared, what we can do here, we know that when we square a number, to do the opposite of that is to take the square root. So we're just going to take the square root of all 3 of these numbers. So we have 9. We're going to take the square root of 9, which we know is 3 from Algebra 1. We're going to take the square root of 16, which we know is 4, and the square root of 25, which we know is the value of 5. Now, when you have all 3 of these numbers, you will see that they correlate one by one, that each number is only off by 1 unit. That is not always going to be the case with these right triangles in Pythagorean theorem, but this is a special triangle case that that's very known in the geometry world. So definitely an important one to take note of. We're going to take these 3 values, 3, 4, and 5, and plug them into our equation. So we know that the right angle, the line across from the right angle, is going to be called the hypotenuse because it is the largest side, and the other 2 remaining sides will be referred to as legs because they are less than the hypotenuse. So we're going to use 3 and 4 as our A and B. Either of these could be interchangeably for A and B. Either one will work, but for C, we know that it has to be the value of 5. So we're going to plug these in. We're going to say that 3, just to say in numerical order, 3 squared plus 4 squared equals 5 squared. So we're just taking the A, the B, and the C, and we're plugging in these numbers for those variables. So we know that 3 squared is 9 from what we found earlier, 4 squared is 16, and 5 squared is 25. Now if we add 9 and 16 together, we are given 25, which means that we have 25 on both sides. So what this does is it shows you that this theorem remains true, that this equation works, and you will have the same value on both sides. If you don't have the same value on both sides, then there's something wrong either in the operations or that this triangle does not all work for a right triangle. So we're going to look at example 4, and we're going to be solving for side A. So we just looked at our equation. Now we're going to be rewriting it and applying it. We're going to say a squared plus b squared equals c squared. Now it shows us here that we're looking for side A and we're given two other sides. We know that the hypotenuse side is across from the right angle, so that will be 7. So we will plug 7 in for C, and we will plug 3 in for B because we're looking for A. So now you should have written a squared plus 3 squared equals 7 squared. Now from earlier we know that 3 squared is 9, and we can say that 7 squared is 49. So we're going to use our Algebra 1 concept, and we're going to subtract 9 from both sides. And we're going to have a squared equals 40 because the 9's cancel out. And now we're going to take the square root of both sides and have a is equal to the square root of 40. So we know from Algebra 1 that we can simplify this square root, that we don't have to leave it as 40, but we can separate it and take a square value out of it. So we know that 40 can also equal 4 times 10, so we're going to have the square root of 4 times 10, and that will equal 2 on the square root of 10. So this is one way you can simplify it, or if you plug the value into your calculator, you can use a decimal approximation. Either one will do. So now we're going to look at example 5, and we're looking for side B. We're going to use the same process. A squared plus b squared equals c squared. And we're going to be plugging in 7 for A because we're looking for B. And we're going to plug in 25 for C. So we're going to square both sides, both values. And we're going to have b squared. So we're going to have 7 squared is 49, 25 squared is 625, and so we're going to have b squared equals 576. Now the reason of this is because we're subtracting 49 from both sides. Then we shall take the square root of 576, and it equals 24. So your foldable should look like this. And now we're going to go on to solving for C. We have solved for A and B, and we've went over a little bit of vocabulary. Now we're going to look at example number 3 about Jane and Zachary. So you're going to have a triangle up top and a word problem at the bottom. We're going to use this figure and fill in the information that we're given and solve for what we do not have. So Jane and Zachary start walking at the same point, but Zachary walks 5 feet north while Jane walks 7 feet east. How far apart are Jane and Zachary when they stop? So we know that moving north is a vertical line and moving east is a horizontal line, which means that if we label our equation A, B, and C as follows, if you want to label it like this, the vertical line is A, the horizontal line is B, and your hypotenuse is C, we're going to say that A equals 5 and B equals 7. So now we're looking for side C. We're looking for this missing side here. So we're going to plug in our equation again, a squared plus b squared equals c squared. We're going to say 5 squared plus 7 squared equals c squared. 5 squared is 25, 7 squared is 49, and we're looking for c. So 25 plus 49 is 74. And if we take the square root of both sides, square root of 74, we can leave that in radical form. There is not a way that we can simplify it evenly into a simpler radical. So you can say it is 74 or 8.6 as your value. So now we know how to solve for side C. So as you can see, you have 3 more example problems on your foldable. If you would like to answer those, please do, because there is a GimKit quiz that I have prepared for all of you to answer tomorrow when you come to class. It will be an individual assessment that I will give you a grade for. So please review this video, go over these example problems, and please email me if you have any questions. Thank you so much for watching, and I'll see you all tomorrow. Bye-bye.